What if everything you've ever known, your memories, your emotions, the stars in the sky was nothing more than lines of code, not a theory, not a sci-fi script, but real math that might prove it? Today, we dive into an idea that sounds insane until you hear the details. Physicists and philosophers have debated for years whether our universe is real or just a simulation running on some cosmic computer. But now, there's an equation buried in the laws of physics that might hold the answer, a formula so precise, so out of place, it's as if it were planted. And once you hear it, you'll never look at reality the same way again. If you're fascinated by cosmic mysteries, simulated realities, and the mind-bending edge of science, make sure to like this video and subscribe to Beyond Reality, where we explore the unknown every week. But what exactly is this mysterious equation? And why are scientists treating it like a glitch in the matrix? Let's begin our journey with the man who first discovered something strange. Error-correcting codes aren't just any kind of code. They're precise, purposeful, designed to protect data from corruption during transmission. When you stream a movie or download a file, these codes work silently in the background, fixing mistakes caused by noise or interference. They exist to preserve the integrity of digital information. Now imagine discovering the same kind of system not in a server, not in software, but in the equations that govern the very particles we're made of. That's what James Gates found, not once, but again and again. These weren't abstract coincidences. The mathematical structures were exact matches to known digital codes, like finding lines of JavaScript hidden in a galaxy. But here's the part that left scientists speechless. There's no reason for these codes to exist in natural law. Physics doesn't need them. Nature doesn't use error correction unless it's processing information. So why are they there? Either the universe is coincidentally behaving like a computer, or it is one. And if that's true, who or what is running it? In the next chapter, we'll explore how this theory connects to the very limits of our understanding and the eerie possibility that the simulation could be perfectly undetectable. If we really are inside a simulation, why haven't we noticed? Shouldn't there be glitches, bugs, something obviously artificial? But here's the unsettling truth. If the simulation is advanced enough, far beyond anything we can comprehend, it wouldn't leave mistakes. It would be seamless, flawless, indistinguishable from what we call reality. This idea is known as the simulation barrier, a theoretical point beyond which simulated beings could never detect their own code, because the simulation would be designed to hide itself. Think about your dreams. While you're inside them, they feel real. Only after you wake up do you question what was real and what wasn't. Now imagine never waking up. Some physicists suggest that our inability to prove we're not in a simulation might be the very proof that we are, because any simulation advanced enough to contain conscious beings would also be smart enough to prevent them from discovering the truth. And if that's the case, are we even supposed to find clues like the Adinkra code, or did something go wrong? Coming up, we'll look at why the very structure of the universe, atoms, space, even time may point to a digital origin. When you zoom into a digital photo far enough, you start to see the pixels, the tiny squares that make up the image. Now imagine zooming into reality itself. What would you find? For decades, scientists believed space was smooth and continuous, but recent theories suggest otherwise. According to quantum mechanics and loop quantum gravity, space might be quantized, broken into tiny, indivisible units, like pixels, but in 3 dimensions. Time, too, may not flow continuously. It might tick forward in tiny, imperceptible steps, like frames in a video game. If true, that would mean the universe is discrete, not continuous, just like a simulation. Even the energy levels of atoms aren't smooth. Electrons don't glide, they jump between levels. Why? Because they follow rules, fixed ones, like a system running code. And here's the kicker. The maximum amount of information that can exist inside a region of space is finite, which means there's a limit to how much detail the universe can store, like a file size cap. That's not how an infinite, analog universe should behave, but it's exactly how a simulation would. Up next, we'll follow the money straight to the tech billionaires. who are secretly funding simulation research and trying to break out. It sounds like science fiction, but some of the world's richest and most powerful people are taking the simulation theory very seriously. In 2016, it was revealed that two unnamed Silicon Valley billionaires had quietly funded a team of scientists. Their goal, to find a way to break us out of the simulation. Elon Musk, too, made headlines when he said, "There's a 1 in billions chance we're living in base reality." In other words, he believes it's far more likely we're inside a simulation than in the real universe. But why would these tech giants care? Because they understand systems. They've built virtual worlds. And the more they learn about the laws of our universe, the more they see something familiar: structured rules, limits, repeating patterns. They see code. Some of them believe that if we can understand how the simulation works, we might be able to hack it, to change the rules, to escape or evolve. And they're not alone. Private labs, secret experiments, and even philosophers are now involved in this cosmic investigation. But here's the twist. What if escaping isn't possible? What if the simulation is watching us and adapting? In the next chapter, we'll explore the eerie idea that the simulation might not just be running, it might be responding. If we're truly inside a simulation, who or what is running it? And more importantly, can it see us? Some researchers propose that the simulation isn't static. It doesn't just run like a movie reel. It responds, observes, adjusts. This idea isn't new. In fact, it's eerily echoed in quantum mechanics. There's a famous experiment called the double-slit experiment where particles behave differently, depending on whether they're being watched. When unobserved, they act like waves, but the moment you measure them, they snap into particles. It's as if the universe knows it's being observed. This strange behavior has baffled physicists for over a century. But under the simulation hypothesis, it starts to make sense. What if the simulation saves processing power, only rendering full detail when we look directly at something? Just like a video game engine loads textures when a player gets close. Some theorists go further. They suggest that trying to detect the simulation could trigger safeguards like an antivirus, reacting to a breach attempt, sudden crashes in high-level experiments, inexplicable anomalies in data. Are these just errors or firewalls? And if the simulation reacts to us, what happens when we push too far? In the next chapter, we'll dive into the philosophical heart of it all. Why would anyone build this simulation in the first place? If this is all a simulation, then something built it. But why? There are theories, some unsettling, some strangely beautiful. One possibility: we're part of a massive ancestor simulation, a recreation of the past by a future civilization, curious to see how their ancestors lived. Like we simulate dinosaurs in VR, or run historical scenarios with AI, they may be doing the same with us. Another theory is more experimental, that we are a test away to explore different versions of reality, different outcomes, different choices, a lab for consciousness, or maybe we're entertainment. A hyper-advanced species could be watching our struggles, triumphs, wars, and love stories like a cosmic reality show. There's even a spiritual interpretation that the simulation is a kind of soul training ground, a stage where we experience hardship, emotion, and growth before waking up to something greater. Each theory leads to more questions than answers, but all of them force us to ask, are we here by chance or by design? Next up, we'll explore the biggest twist of all, that even if we prove we're in a simulation, there may be nothing we can do to change it. Let's say this simulation is real. We find the evidence, the patterns, the code. The question is then what? What if we're like characters in a video game, becoming self-aware? But no matter how smart we get, we're still trapped inside the code. Some scientists believe there's no way to break out because there's no outside to reach. Our reality is the reality we know. Even if it's virtual, it's all we have access to. Others suggest the simulation is designed with safeguards, barriers that prevent us from tampering with it, like NPCs trying to rewrite the game there inside. And here's the paradox. If we ever reach the point where we can prove the simulation exists, what if that very act triggers a reset, or worse, a shutdown? Some theorists call it the simulation termination hypothesis. The idea that the moment the system realizes its subjects are self-aware, it ends the program. But maybe, just maybe, awakening to the simulation doesn't mean escaping it. It means understanding it, mastering the rules, and learning to play the game better. Coming up next, we'll reveal the most bizarre twist in this entire theory, that we ourselves might become the next simulators. What if the reason we're in a simulation is because we will create one ourselves? It's a concept called the simulation stack, the idea that advanced civilizations inevitably create simulated worlds, and those simulations create more simulations. A chain of realities, nested like Russian dolls. Think about it. We already simulate weather, economies, and behavior. We train AI in virtual environments. We build entire worlds in games like Minecraft and The Sims. As technology advances, it's only a matter of time before we create fully immersive, conscious simulations, worlds where digital beings believe they are real, just like we do. So what? Are the odds we're the first? The base reality? Statistically, very low. If one civilization can simulate trillions of conscious beings, then the vast majority of minds that exist are inside simulations, not outside them. In that view, we're not just likely in a simulation, we're almost certainly in one. But here's the strange beauty. If that's true, then reality is bigger than we ever imagined, and we may be part of something much more complex, more intentional than a random explosion of particles. Next up, we arrive at the final chapter, a reflection on what it means to live in a simulated world and why, even if it's not real, it might still be meaningful. So we might be living in a simulation, a digital illusion, a cosmic program. But here's the real question: does it even matter? When you feel love, joy, pain, when you stare at the stars, or hold someone's hand, are those experiences any less real just because the code behind them might be to us? This world is reality. Our choices, our memories, our emotions, they shape who we are. And if we are in a simulation, maybe that's not something to fear. Maybe it's an invitation to live more consciously, to ask deeper questions, to recognize the patterns, to play the game not blindly but with awareness. Because in the end, whether this universe is made of atoms or algorithms, we still write our own stories, and that makes us more than just code. But what do you think? Are we digital minds in a cosmic simulation, or just curious beings reaching for answers in the dark? Let us know in the comments. And if this journey made you question reality even for a moment, leave a like, subscribe to Beyond Reality, and share this video with someone who loves a good mystery. Until next time, or stay curious.